Next up, we have the law of sines. So the law of sines, we are now getting into solving triangles with missing lengths and missing angles. So there are two different ways you can solve them, and one is law of sines and the other is law of cosines. Today we're going to work with law of sines, and then 9.4 is on law of cosines. So it says you can use the law of sines to solve triangles when two angles and the length of any side are known. Because if you have two angles, there's only one missing, and those two and that one add up to 180. That's using the triangle angle sum theorem. I'm going to do that, shorten it. So the triangle angle sum theorem states that all the sides of a triangle must add up to 180 degrees. So that's the first condition, and we can call that by, if you go back and think math 2 when you guys did your geometric proofs, that's angle, angle, side, or angle, side, angle. The other case, which is not done in math 2, but you can use it here, is when you have two sides and then an angle opposite of one of those sides. So there's two conditions to it. And then you can find the missing angle that goes with that side. So, and that's side, side, angle. The theorem states if you have the side length and the angles, they are proportionate to each other. And there's a proof you guys can see on page 492. But they are proportionate in like a ratio to each other. So whatever you do, sine A over side A, that will equal sine B over side B, and sine C over side C. And then it can go either way, so you can flip the fraction back and forth. So an example, let me just draw two different ones. We're not going to solve them. 8, 12, what is this? Okay, so two angles, and then, well, let's just do 4, let's do 68. Okay, so you'd be able to set it up as sine 68 over 12 equals, we'll call this side A, sine A, because you don't know that angle, over 8. And then you can go from there and solve. Once you then find a second angle, you can add them up and find that missing angle. And then the other one is if you have two angles and a length. So say we have 38, 41, and we'll call this 6. You can set this up as sine 38 over x, we'll call it, because we don't know. And then sine 41, I'm running out of room, over 6. Then once you get to this point on both problems, you'll cross multiply. Now, this case is a little more complicated. It's going to teach you a new thing in your calculator, which you did use in math 2, but you haven't used it so far this year. So we will get to that in these examples that are coming up next. Make sure to have, I would say, at least that I just boxed. Sine A over A, sine B over B, sine C over C.